After completing this lesson, you will be able to prepare the design for computational fluid dynamics, connect the design from Fusion 360 to Autodesk CFD, and review the Autodesk CFD interface. To begin, use the New Design from File tool to open the F1CAR CFD Fusion Archive file. An important note: the connectivity between Autodesk CFD and Fusion 360 is available only in Fusion 360 Ultimate on the Windows platform. To begin, use the Create New Design from File tool and open the F1CAR CFD Fusion Archive file. Once the design is open, be sure to save it to your project. Next, switch to the Simulation Workspace. In the Windows version of Autodesk Fusion 360 Ultimate, you have the option of going directly to Simplification. Instead of selecting a study type, choose Simplify Geometry for use in simulation and select Simplify Model. When the model opens, all of the bodies that are present in the design will be visible, including the two freeform bodies that were used to add curvature to the top and bottom of the car body. Expanding the Model Components folder in the browser will expose the various components and bodies that make up the design. Expand the car body component and expand the Bodies folder. Then select the two freeform bodies, right-click, and select Remove. This will remove these bodies from the simulation model. Anything that's done in the simulation model will not affect the actual design model, so you can be very free with your modifications, as you'll see in this lesson. Next, expand each of the wheel assembly components, selecting all of the bearing instances, and remove them as well. In the Simplify workspace, we can use modeling tools that cross over multiple other workspaces. The next step we'll choose is to use the cylinder primitive to cap off the end of the wheel by creating a cylinder that matches the diameter of the bearing relief and matches the full depth of the boss in the wheel. We'll join that to the wheel, and the instances on one side of the car will both be updated. We'll repeat the process on the other side of the car, adding cylinders to fill in the wheels on the right side. When this is done, go under the Modify pull-down and select the Combine tool. Then choose the main body of the car. With the operation set to join, select the rear wing, the front wing, each of the wheel assembly instances, and then the axles. Then click OK. This will fuse all of the various models into the car body, as that was the target body. Just for clarity and simplification, we can select the remaining components and remove those from the design as well. Next, we'll go under the Create pull-down and select the Fluid Volume tool. A fluid volume helps to prepare the model for computational fluid dynamics. Make sure the volume value is set to External and select the car body as the tool. Then offset the fluid volume 40 mm, clicking OK when ready. To get a better idea of what's just happened, we'll use an appearance override to apply a water appearance to the model. Dragging the appearance onto the fluid volume, we can see that the car body is still in the center of the fluid volume, but when we turn it off in the browser, we can see the entire component has been subtracted from the fluid volume. Let's do a quick rename of the fluid volume, and then we'll use the Press Pull tool to add 80 mm to each end of the fluid volume. Then, to offset the bottom surface up 40.1 mm so it just intersects with the bottom of the tires. We'll do this simulation as a half volume. The last step with the fluid volume is to cut it in half, moving it in till it intersects the YZ plane. When we click OK, we can see that the void is now cut in half as well, and we can turn off the origin planes. Our model is now ready to go over to Autodesk CFD. Clicking the CFD icon in the toolbar will open the dialog box where we can establish a study name, a design name, and then a location for the study to be created. When you click Launch, it will open the model in Autodesk CFD. You might have to reorient the view cube based on the direction of the axes in your model. We can close the output bar for some additional view space, And then let's take a moment to review the basics of the Autodesk CFD interface. The toolbar that's visible now is the Setup toolbar. There are a series of steps going left to right that you can use to prepare the model for computational fluid dynamics. You can set the material for what you're analyzing, establish the boundary conditions. If you want to set up initial conditions or motion, you can do that as well. And of course, you can set up the mesh and then solve the model. The right half of the toolbars, as they change, not just for setup, but results and other stages, allow you to access tools for editing the values or removing conditions. The workflow that's presented in the toolbar is also represented in the Design Study bar on the left. This looks very much like the browser in Fusion 360 and also helps you to keep track of the setup and results. First, let's select on the component. You'll see that the material is unassigned. We can choose Edit at the end of the toolbar. And in the Materials dialog, we'll keep the type at Fluid, but change the type of fluid to Air. You'll see the volume changes color to match the new material. Next, we'll set up the boundary conditions. But before I do that, I want to make sure that the car model geometry is using the correct units. I'll right-click on the geometry and change the units to meter. Then we'll apply a transient velocity to the front of the car. Since the car will be accelerating down the 20-meter track, we'll take a look at how the airflow will change as it accelerates until it reaches its top speed. Clicking on the front face and then selecting the Edit icon from the mini toolbar will bring up the Boundary Conditions dialog. The default value that appears is velocity. Confirm that the unit is set to meters per second, and then change the time to transient. There are a number of different ways to apply the time curve. For this model, I'll use piecewise linear. Selecting on that and expanding the time curve dialog, we'll enter values. The value will be the velocity. The time value will be at what point that velocity is reached. We'll start out with 0 and 0, then go to 1 meter per second at 0.2 seconds, then 5 at 0.3, 10 at 0.4, 20 at 0.5, and leaving it 20 all the way out to 1. We can then click on the plot to see what the curve looks like. Studying your car and taking a look at historical testing, you might be able to come up with a much better curve than this, but we'll use this for this example. And then click Apply. Next, we'll pick the midplane of the model, change the type to Slip Symmetry so that the model knows that this is a midplane of a model and it's a symmetric model. Then we'll rotate the model and select the very back, changing the type to Pressure and making sure the value is set to 0 so that there's no resistance behind the car, allowing the air to flow freely over the body and out the back. We'll bypass any initial conditions, but select Mesh and choose an auto size. Now our study is ready to be run.